So this is the last video on quadratic equations, and it's to do with problem solving. So we've just got three examples to do. So the first one, the sum of a number and its square is 42, find the number. So we're not going to use trial and error, we're going to create an equation and go from there. So we have the sum of a number and its square. So remember, to start with, we need to say let the number be x. So we've defined our variable, and we've got the sum of a number with its square, so it'll be x plus x squared equals 42. And I want to find the number. Now we see this, and we should be able to notice that this is a quadratic. And we can rearrange it so it equals 0. Now here we've got to think about how we're going to solve this. So to solve this one, we can either do factorisation, completing the square, or the quadratic formula, you take your pick. I'm going to do factorisation because I've looked at it and I can see that we will be able to do that. So I want two numbers that multiply to get negative 42 that will add to get 1, and I will find that they are negative 6 and 7. Which means I can write those two numbers in my bracket. So then we know that x minus 6 will equal 0, or x plus 7 equals 0. So x will equal 6, or x will equal negative 7. So there are actually two solutions to this question. All right, example 2. A rectangle has length 5 centimeters greater than its width, and its area is 84 centimeters squared. Find the dimensions of the rectangle. So the first thing I'm going to do is draw a rectangle. All right, and what do we know? It has a length 5 centimeters greater than its width. So I'm going to define, let the width be x, and the length is 5 centimeters greater, so it's going to be x plus 5. And we know the area equals 84. So from here, if we know the area equals 84, the area of a rectangle is length times width, which we know that's going to be 84 equals the length, which is x plus 5, multiplied by the width. And now we're just going to solve this. So the first thing we have to do is expand the brackets, and then rearrange it. Oh look, it's a quadratic, so we're going to make it equal 0. So I look at this and go, can I think of two numbers that multiply to get negative 84 that will add to get 5 to use factorisation? You find you can do it, but it's a harder one to see. So once again, complete the square, use your quadratic formula, or if you're allowed a calculator in this type of question and exam, use your calculator. And if you do factorise it, you would see it would be 7 and 12. So it would be negative 7 and positive 12 if we were to factorise it. So we'll have x minus 7 and x plus 12. So when we are solving this then, we know we're going to have x minus 7 equals 0, or x plus 12 equals 0. So x will equal 7, or x will equal negative 12. Now, you've got to think about the context of this question. X is a length, which means it can't be negative. So x equals negative 12 is not a possible solution. And our only answer here would be that would x equals 7. So the width will equal 7, and it means the length is x plus 5, so it would be 7 plus 5, which is 12. So the length is 12 and the width is 7. So we've got example 3. Given that AB is 3 centimeters shorter than BC, find the height of the flagpole. So the first thing we're going to do is define our variables. So we're going to let the height be x meters. Okay, so that's the height of the flagpole. Now, the little double lines that you see here, I'm just going to draw a quick circle, means that these two sides are the same length, which means this bit here will also be x. And the question also tells us, so that means we can also say that BC equals x, and we know that AB is 3 meters shorter than BC. So AB will equal x minus 3. Now when we have a triangle inside another triangle, as we do here, we've got a smaller triangle and a big triangle, the ratios between the corresponding sides is the same. So if we look at the flagpole side, which is x, the corresponding side in the smaller triangle is the 2. So the ratio of that has to be equal to the ratio of the base of the big triangle divided by the base of the smaller triangle. Now the base of the big triangle will be x plus x minus 3. So that's the whole length of the bottom divided by that length of the smaller triangle, which is just x minus 3. So because these triangles are similar and they're inside one each other, ratios of corresponding sides are the same. Now from here we can simplify things down, so we're still going to have x over 2 equals x plus x, which will be 2x minus 3 all over x minus 3. Now from here we want to get rid of the fractions so we can cross multiply. So we'll have x times x minus 3 equals 2 times 2x minus 3. Expand out, so we'll have x squared minus 3x equals 4x minus 6, and you'll be seeing now it's starting to look like a quadratic. Take everything to the one side of the equation to make it equal 0. Now we have a lovely quadratic. Once again, solve however you like. These can all be done with factorization, so I'm going to do that again because it's quickest. So we'll have x minus 1 and x minus 6, and that means that x minus 1 equals 0 or x minus 6 equals 0, so x can equal 1 or x can equal 6. Now we have to think about the context of the question. Are both these lengths valid? Now if we look at the length of the smaller side, the AB, we said that's x minus 3. So if we used x equals 1, we would get a negative value. We'd get 1 minus 3, which is negative 2. So that means that this option here is not possible. So it means our only possible solution is x equals 6. So therefore, the flagpole is 6 meters. And that is some lovely problem solving for you.